if you have an electron withdrawing group or electron donating group on your molecule. In this lesson, we are going to focus on electrophilic aromatic substitution because the presence of electron withdrawing and electron donating group can change the reactivity of the molecule. When a benzene ring with the electron withdrawing group react with the electrophile in electrophilic aromatic substitution, the electrophile will be added to the meta position. From this reaction with the electron donating group, we get the introductions of the new electrophile auto and para to the electron donating group. So we can say that this electron withdrawing group are the meta directors and the donating group are auto para director. Now, electron withdrawing group are just how they pull electron out of the ring. The electrons are being pulled up toward this electron withdrawing group out of the ring, and so it's a less reactive. This ring with electron withdrawing group are deactivated. Conversely, this electron donating group have an electron that can donate into the ring.
Hi everyone, I'm Hazira. I will explain to you about reaction of benzene derivative, which it has two reactions, which is reduction of nitro group and also substitution reaction of diazonium ion, which is salt. The first reaction is reduction of nitro group. It is treatment with zinc, tin and iron with dilute acid that will reduce the nitro group to an amino group. And next is substitution reaction of diazonium ion the reaction of aniline will form arene diazonium salt. This arene diazonium salt can be used to prepare substitute benzene, such as phenol and aryl halide. It reacts with nucleophile. This is the example, arene diazonium salt that will produce phenol, and this is nucleophile that we react with.
And for the second derivative, we came across to the side chain reactions of benzene derivative. Side chain reactions of benzene derivative is divided into two, which are the free radical substitution reactions and the oxidations of alkyl benzene. And for the free radical of substitution reaction is undergo halogenation process. For in this chapter is about the alkyl benzene. And for the oxidations of alkyl benzene is about the side chain oxidations. In halogenation process, which we learned from the previous lessons, it involving the chlorine and bromine with the presence of ultraviolet rays and with a high temperature. And for the mechanism, just like the previous lesson, which are the first one are the initiation process, where bromine undergo process with the presence of ultraviolet rays forming two molecules of free radical bromine. And for the second step, which are the propagation process, in this case we choose 2Li. Undergo process with free radical of bromine and the product is where the loss of one hydrogen and the attachment of free radical at the carbon. And one of the hydrogen is evolving into the HBr. And this product is undergo another reactions with bromine, forming the benzene ring, which has the attachment of CH2, Br, and free radical of bromine. And for the last step, which are the termination process, where two radicals match and terminate the process. For this example, we take free radical of bromine and another free radical of bromine became bromine. And these are another examples of it. So, for the oxidations of alkyl benzene, which involving side chain oxidation, where the alkyl benzene is oxidized, becoming benzoic acid. Oxidize of alkyl benzene is by heating in acidic KMnO4 or potassium permanganate, or heat in Na2Cr2O7 or H2SO4. For this oxidized process, it must possess at least one benzylic hydrogen. Benzylic hydrogen is where hydrogen atom bonded into carbon atom, which is bonded directly to benzene ring. For this, we can see, for example, benzylic hydrogen is toluene, where hydrogen atom is bonded to carbon atom, which is bonded directly to the benzene ring. If no benzylic hydrogen is present, there will be no reaction occur. For example, we take toluene, undergo oxidation process with hot KMnO4 or Ne2Cr2O7 or H2SO4, we get benzoic acid with attachment of C double bond O or H. Thank you.